Hey everyone, how's it going? Happy Tuesday. We're going to be continuing with our convolutional neural network. We're going to make sure that our model works pretty well. We're going to train it over some animal pictures. And then we're going to put all that output into TensorBoard, which is the whole point of the tutorial. It took us quite a while to get here, though I think we're going to finish today. We've said that before, so maybe you'll never know. You'll never know. I think we're going to find out. Oh, I forgot to click the send button here. Oh, 1 second. Clicking the send button. There we go. Wait, send. Yep, there we go. Perfect. Okay. So this is our tutorial, and we're going to walk through it right here. We've got our optimizer, and then we're going to do backpropagation. I believe we've already achieved this here. So we've got optimizer and backpropagation. I do want to try. I want to try this real quick. I want to change the criterion. Wait. Hold on. What did I have it at before? I don't remember. I'm going to try this, though. Okay. Let's see here. Starting epoch. Okay. And I've also added... let's see. Oh, negative. Whoa! No. Whoops, that's a problem. Hey, Torva, how's it going? Good to see you. Happy Tuesday. We just happen to have a very big number problem. It's like the AI is learning in the reverse. A negative, very big number, E plus 21. That's huge. Hey, Proud by Core, good to see you. Welcome on back. We also have Haramana. Haramana, welcome on in. Thank you for clicking the hi button there. Jens8534, welcome on in. It's unlearning. It exactly. It's like I'm showing it the right answer, and it's like, nope. Like, no, this is the answer. It's like, no, right here, learn this. It's like, nope, not gonna learn. And it just kept doing that until it got to a very big negative, very big number. E plus 2100. It's a big number. All right, so I guess we can't use that criterion. Let's use this other criterion here. All right, this one I think works. I think this one works. There we go. That's a little bit better. And it's learning. There you go. Very slowly. Very slowly. We're going to have to change our model up a little bit here. Let's change our model up. Okay. I think we need to modify how this is working. I think this needs to change right here. I think some of this is going to happen. We got down to 3.63, which is not a lot. It needs to be closer to 1. And what is our learning rate right now? Learning rate is 0.01. Okay. What if we reduce the learning rate? I'm going to try that just to mess around with it real quick. Just to see. Oh, whoa, that does way better. Okay. Our learning rate was just a little too big. You're working on your PS1 emulator written in C? Are you serious? What? No way. You got to tell us about that, Prod by Core. Tell us more. Tell us the details. I'm kind of curious about that. Let's see here. Is that going? Okay, good. How's it going there, Kyle? Good to see you. Welcome on in. Happy Tuesday. Hope you're being productive and happy and satisfied. It's always great when you're being productive and happy and satisfied, isn't it? I think that's great. Thank you for the hearts, you guys. Appreciate it. So we get down to 3.2 that time. What if we even did... Let's see here. What if we did this? Let's see. All right, 0. What if we reduce the learning rate even further? Let's try it. Let's go even further. Will that make it better or worse? It just doesn't do anything. All right. So this is our target learning rate. And are we using a GelU or ReLU? I think we're using a ReLU. Oh, we're using GelU. Okay. What happens if we do gel? Let's see. Let's change up to a ReLU here. Rel. Is that all the gels? Oh no, there's more than one. Okay. I'm gonna see if this makes it any different. Because I like the GelU better. Also, I want to try the Muon. So look at the Muon right here. I want to try the Muon optimizer because right now we're using Atom W. So that's a couple of things. All right, so let's see here. Let me get my to-dos going here. Where are we at here? All right, so let's get a few to-dos here. I'm gonna use Muon. I want to see if we can get the negative log likelihood loss working. Let's see, OSS. Loons, hey Loons, good to see you. Welcome on in. You tried to be the earliest possible. You did good. You did good. You're like, we only started a few minutes ago. Hey, Jens, you discovered your channel. Oh, you discovered the channel like 3 weeks ago. Nice. And it helped you a lot. That's great to hear. For your National AI Olympiads last week. No way. Thank you for your video. I improved a lot. And I may get to the International Olympiads. No way. Really? That's great to hear. Jens, good job. Good job, Jens. You did it. You did it. Loons, you think's your record? Well, yeah, so that's 6 minutes. You made it in at 6 minutes, so that's a pretty good one. GG, Jens. Good job. Good game. Good game, Jens. All right, so I want to do muon, latent log, negative log likelihood loss, and then let's see what was else. Oh, we have to. We'll try ReLU. We're gonna try ReLU. We're gonna do that right now. We're gonna do that right now. ReLU activation, and what else? I wanted to. We need to update the model. Update model. The convolutions, and maybe a different kernel size. Let's see, kernel size. I think the best one is 3 is the answer, right? Size of 3. Reduce images. Let's see, reduce images. And then I also wanted to add in the TensorBoard. So let's add in the TensorBoard. So TensorBoard output loss graph, which is the whole point of the tutorial. In 1 to 2 minutes. It's pretty good. You made it. You did pretty good. You're making your new personal best. Okay. So how do we do this? We can add a scalar. I don't log the running loss average per batch. See, now I've never done this right here, so I don't know what this means. So we're going to try it. I've never done this before. And I've got our epoch, which is going to give us our, and then we're going to have a different, oh, interesting, training and validation. Oh, and it knows what it means? Okay, so this might be a graph with 2 lines on it. We're going to find out. We're going to find out, you guys. You're planning on health routine this morning? Like, what kind of health routine? Trying to eat more vegetables and getting fit. There you go. Eat vegetables. That's what I did. I ate vegetables, yeah. Cauliflower, broccoli, we had green beans, peas, some corn, onions, and we had garbanzo and kidney beans, and then a grain mix. I had, what is it? Quinoa, millet, oat grouts, brown rice. Like, did you know you can mix grains together? You don't have to use all the same one at the same time. You can mix them up. If you knew that. How's it going there, Kraken? Kraken, welcome on in. Shake some lettuce. Exactly, right? Get the breakfast in. You'll thank me later. Shake the lettuce. Well, I've been doing some. I like kale and what do you call it? Arugula or rocket. I like those. Though I kind of got bored of them, and so now I'm doing just broccoli. And you get everything you need from broccoli. You do. You don't need anything extra. You don't need anything beyond broccoli. You don't need to do extra leafy greens. Just eat broccoli and you're fine. Also, I really like broccoli. I like a lot. What I miss is kale. I know it sounds weird. You're like, no, wait. I stopped eating kale because it just took so long to prepare. Because you really have to like wash it good. And some people like to boil it for a minute or 2 just to, sterilize it. And it's just too much work. I'm just going to steam broccoli. That's what Brian Johnson does. Was it Brian Johnson? Yeah, I think so. Is that right? The guy that measures everything. Okay. Data iterator images. Add graph. Net and images. Flush. What is this? Add graph will trace the sample input through your model. No way, as it renders as a graph this whole time? All right, I like this right here. This is really easy. All right. What about images though? It's only going to get 1. That doesn't make any sense. Why would you only add 1 graph? We're going to try it and see what it does. All right, we'll try it and see what it does. Kill goes too hard, does it? Lettuce is delicious. Some lemon and you're good. Squeeze a bit of lemon and you're good. That does sound actually really good. Yeah, I'm with you on that. Yeah, iceberg lettuce, very tasty. It is pretty good. I like it, pretty good. And then we'll go through this. Okay, so we've got a lot of tasks here. I didn't even know what this section is. Access to healthy food shouldn't be this hard in the US. It shouldn't be. Well, it's because all the aisles are filled with the really easy calories that are not good for you. The processed stuff your body is not ready for. And then all this like buildup can happen in your body. Are you eating animal products? You're gonna have gallbladder problems. Are you eating too much calcium oxide things? You'll have like kidney stones, which is a problem. And are you eating, you could clog your arteries if you're eating too much animal products, or if you're eating those, processed foods. Like all this problems will have, it's what you call it, it's an illness. It's, what do you call it? Illness, voluntary illness is what you're choosing based on what you're eating. You get to volunteer for your own illness. You are choosing it. I know it. All these foods are really tasty and addictive. They are. The candy, right? Which can give you diabetes, or, the animal products, they're really tasty, right? Animal products, they're going to give you a whole bunch of other problems. It's a voluntary illness, you guys. Why you GE? What's that? What's the GE? Why you age, maybe? Adrian Hari? Are you saying why you age? Your body has a built-in DNA mechanism change that, for evolution purposes, require you to have a maximum life. In the early age of life, there were animals that did not have that attribute. And what would happen is they'd multiply until they exhausted all the resources in the area, and then the entire population died. So only this is my hypothesis. I'm making it up. I think this is why we age. You're going on Twitch? All right, Loon, sounds good. Oh, hey, you're already on Twitch. Hey, look at that. Am I mod here? Can you make me mod here, please? Yes. Okay. How do I do that? What is this? Click to reply. Yes. We need to do that. All right, 1 second, you guys. How do you do this? Click. Gift. I don't know how to do that. Do you guys know? What is this? Oh wait, I think I just did it. Here we go. All right, you're good now. Now there you go, Loons. All right, success. I think you did it. You're good to go. Wait, are you coding Python? Yes, I am. Zero Gaped. Zero Gaped. We are absolutely doing Python. He's a software engineer. Zero Gaped. Yeah. How do you get subtitles on the live? Oh, I've got that ready for you. So we've got subtitles right here. This is software I wrote 8 years ago. You can see right there, a little bit of 8 years ago there, some 8 years. And it allows you to add subtitles onto your live on Zoom, on Microsoft Meet or Teams, Google Meet, whatever you want to do, you can add them. Hello everyone, hey JM, good to see you. Welcome on in. Happy Tuesday, good to have you guys here. Yeah, and so you can have these subtitles here. So check this out. I'll paste this over here on the link share again because it's very often. Link share, here we go. Ooh, we got an open source here. What is this? The open source AI lie. Washing. Broken definitions? Who benefits? No major AI models meet the open source definition. Who's faking it? They are. They're all faking it. They're faking it. All right, this is for the stream here. I'm gonna remove that here real quick. There we go. Okay. That's sick, bro, isn't it? Zero Gape, yeah. You can. It's right here on Discord. So if you want it, you can. It's open source and free forever. How's it going? Code Mitsu, good to see ya. What's up, broskies? Welcome on in. All right, let's get back to our tutorial here. All right, we've got a lot of tasks here. We got a lot of tasks, and then we need to finish the TensorBoard tutorial, which we should be able to do today. I think so. So there's a lot of things. These things are going to be really fast right here. We can do those really easily. Good to see you, bro. Good to see you too, Mitsu. How's it going there? Neg Lego. Hey, Neg Lego, welcome on in. Sigma Edits, you're here too. Hey, welcome on in, you guys. We're all jumping on back. Good to have you here. All right. So let's get back to our code here. Good to have you here. Thanks, man. Thank you. Thanks for stopping on in and saying hello. We're going to be some coding convolutional neural networks on our journey to become a Pytorch expert. You're going to watch as I work through all the tutorials and mess with the code while I learn how to become a Pytorch expert. We're pretty good now. We know most of our stuff. So I want to mess around with this really quick. Do we need to pool everything? Do we always need a pool? And then we're also going to, do we need this many conv nets? So there's a lot of stuff that we have to do here. Every time we make a change, we have to rebalance our inputs and outputs between each of the layers. Hey, Donut Dude LFG, that's great. What are you giving away? Oh, giving away knowledge. More AI hype. Yeah, exactly. That's what we're doing. Join the Discord, you guys. Thank you, Kyle, for mentioning it. Thanks, mod tools here are 10 times better. Nice. Oh, nice start. Yeah. That's actually the best method. Can't learn without proactive trial tests. You got it, Codemitsu. We got to mess around with this. All right, let's do... Oh, so did we try ReLU yet? Let's try it. Let's see what we get with ReLU. GeLU did a little bit better, to be honest. I think our GeLU... Look, ReLU's having a problem. It can't even barely... We needed GeLU. We needed it. Let's try negative log likelihood loss real quick. Let's see if we can do anything here. Yeah, GeLU is way better. Unless we need to increase the learning rate. We might need to do that. Let's see. Nope. All right. It did not like that. It does not like that. As you can see here right now, what you're looking on the screen is a problem. You won't be able to stay long. Oh, but you're excited. Oh, thank you, Donut Dude. Glad that you got to say hello and visit for a bit. Just talking something we can use forever. Oh, okay. So we are having a hackathon later. Not today, not this week, maybe not next week, but maybe the week after. I will put when I know the date, I'll share it, and there'll be like prizes and stuff, and it's something you can use forever. You can use it forever. So negative log likelihood loss is not good. However, with ReLU, do we need a larger learning rate? There we go. A little bit of errors there. All right. Yeah, ReLU likes bigger learning rate. It does. I think I'm going to go back to GeLU though. Let's go back to GeLU. All right, so we'll do this. ReLU with GeLU. There we go. Okay. Yeah, all right. In LLL. We need to not have that one because obviously it's a problem. There we go. HS, good to see you. Welcome on in. Oh yeah, it's Tuesday. It's Tuesday. All right, so it likes that. It likes that well. Okay, let's see if we can mess around with more of this up here. I think we need to. So this is our ConvNet 1, and we're pooling here. Do we want to just pool straight out like this? What if we just did this? Wait. We're gonna need to do input. All right, let's mess around with that. Is that gonna, I think that should work without crashing. No, okay. So we do have to modify it because we're pooling a lot more. Okay, here. Let's just try it. Let's just try this. All right, let's mess around with this. All right, we need expected input. Got 2633, which is up here. Oh, right, okay. 1 second. Let's do 1 and let's do 3. Can we do that? No, we can't do that. We can't do that. Okay. Because of how everything's aligned up here. I guess we'll mess around with it. Fine. We'll mess around with it. We'll find. Oh, hey, Loons, thank you for the pin. I didn't know you could do that. That was pretty neat. Hey, Quantified Quantum, welcome on in. Good to see you. Happy Tuesday. We're continuing with our CNN. Convolutional Neural Network. Okay, I want to also grab this here. We need to change this up here. Because we're going from 1 to 2. Let's go to 1 to 2. Let's just do 1 to 2. 1 to 2. And then what we got to do is this your goal? You just did it, Kyle. Whoa, check that out.
This is your goal.
Thank you. You just did. I was not expecting that to happen at all. Kyle, thank you. My gratitudes. Thank you, Kyle. Shout out to Kyle. Flip with Kyle, you guys. Thank you. Explanation point. And then some party poppers. It's always gotta do the thank you. Thank you very much, Kyle. So what you basically, obviously, we do this anyway for you, Kyle. However, if you've got a link to share and it's classroom safe, we can take a look at it. We could take a look. Ooh, check this out. Explanation. Exclamation. See, it's got some weird little syntax things. I need to fix that. That's a bug. We found an exclamation bug. Oh, yeah. So Kyle, yeah, if you have any links to share, if you have anything to share to links. All right, set another goal. La la la. Okay. Let's see. Another one. Okay. Anything you got? Extra curly brace. I know, code me too, right? It's like, why is it there? I have no idea. Oop, Loons, thank you. Thank you for the links. All right. So let's see here, you guys. So we've got our inputs. We're just gonna reduce this down. We're eliminating these two lines here. So we got that line, and then we got this other line over here, right? So we got rid of those, and then we're only having 2 layers here. When we do this, though, it's going to ask us for a specific size, which apparently it didn't. Oh, is it learning a lot better now? Yeah, that's learning a lot better. Look at that! Look at it go! Steven, you heard? Maybe, we're going to find out in a second, that you are having a breakthrough in stopping aging in China. Wait, they are having a breakthrough in stopping. Are you serious? Really? Did they find the aging genes? Because here's my theory. I just explained this like 10 minutes ago, though I'll explain it again. Aging is a built-in mechanism for a species, and it's by design, through nature and natural selection. Because there have been species that didn't have this gene populated so much that they exhausted all the surrounding natural resources, and there's nothing left to eat. So they went extinct, the entire populace. And only those with the gene mutation that allowed them to age and, maintain a stable population were able to propagate. And that's what we're left with today. Hey, Dreamer, welcome on in. Good to see ya. We're just talking some health today. Stopping aging or slowing aging. We know we can slow aging a smidge, right? And I don't trust the thing in China per part. Yeah, exactly, right? I know. They always make these big claims, and you're like, I don't know about that. I'm suspicious. I'm suspicious of what China say. How's it going there? Ciaritham. Hi, Unc. Welcome on in. Yep, we are Unc. You used the proper term. Good job, sir. Good job, sir. Or bro, however you want to say it. Okay, I want to... apparently, I don't know how we did this. I have no idea, but it works a lot better now. Look, we got down to 2.9. We got down to 2.9. Heard aging keeps a side caption America direct from Frozen come in chat. I have no idea. Dreamer, I don't know what you're saying. You're really good at saying words a whole bunch. How do you get those subtitles? Oh, Sriatham. These are in our Discord, so you can see it's open source. This is code that I wrote many years ago for your YouTubes and stuff. Oh, whoa. Hey, 1 year of Torva, thank you. Whoa, that's amazing. Torva, what are you doing over Torva? All right, Torva, thank you. Exclamation point. A few party poppers in here. Torva, whoa. I was unexpected. I appreciate it very much. My gratitude, and indeed seems to be the goal, Kyle. It does. Did you reach it? Let's see. We're almost at the goal. How do we get the subtitles? Oh, I was going there. Jiao X Yo, the subtitles. Yes. So they're in our Discord. You can get the subtitles, and they work in OBS, which then you can also use in, Zoom, Google Meeting, Microsoft Teams. And you can have live subtitles over your output. Isn't that neat? You can do it. Yep, so it's right here in our Discord. Just click this link, share link right here. You click that, it's gonna open up a new window, and it's gonna give you instructions on how to install it yourself. It'll work. Quantified Quantum used it and proved it. Steven, captions like this, you need to use web, Google's speech to text, then broadcast via WebSockets. Yes, exactly. Mm-hmm. And is there a package JSON And so you can see, let's see here. Only dev dependencies are needed. There is, no, in JavaScript here, it's called JS. There is a library called subtitles. Does this it right here? Yeah, right here. And that does the majority of the coding here that you need. That's where all the answers. This incredible, dude. What? I know, right? Completely open source, free. You don't have to pay for a single thing. It's absolutely free. What is your content about, by the way? You're new? All right. We do software engineering here. And my name is, let's see here. Let's see if I can scroll over to, where am I at here? Here we go. All right. My name is Stephen Blum, CTO at PubNub. Technology company that is for communication APIs, which is what we're using right now. You see on the screen these subtitles right here, subtitles. They are actually powered through my technology. Communication that requires you to have an open browser window. So you have a browser window, and then you can pipe that data into OBS. We see here's OBS right here. So that's one of the use cases for my technology. Obviously, we've got a lot more use cases. Just a few. Are you guys hiring? Yes, we are. So let's go to PubNub Careers. Let's see. Do we have a careers window open? I think we do. Yeah, here's my website. Go to my website. Go to our careers. And we've got a senior backend engineer for AI and large language model systems. And we have a senior solutions architect. So we got 2 open software engineering roles. Steven, you recently heard about IPv8? There's no way. There's no way. There's IPv8. We don't need a Night 8. We only need 6. 6 has 433 trillion possible addresses, right? You don't need any more than that. Or is it trillion? I can't remember. It's a number that's so big, every device can have multiple IP addresses, and you don't need NATs anymore. You don't need network translation tables. Senior, it means I have a lot of experience, right? Seniors, you got it. Well, we're looking for the experience. Although apply regardless. I always say swing at everything. Swing at everything. Steven, if you need an intern, I'll be available. Quantified Quantum, really? Okay. So that is something that we are considering. Quantified Quantum. Let's stay in. Send me a DM because I'm pretty sure we're gonna have an intern, just one, maybe more than one, maybe more than one. But right now I'm thinking one for now. Steven, if you need an intern, you'll be available. Good to go. Send me a DM. Looking for an intern. There's no official start for this yet, so it might not happen. Though I'm pretty sure we're gonna. Torviz European, I don't know, flashback to LinkedIn. It's still a concept. Cool on now, doesn't. All right, nice. Oh, okay, yeah. So very likely intern, yes. You're going to message you on Instagram, Steven. All right, sounds good. So I'll be ready. I'll be ready for you. Got your open roles here and maybe an internship. Maybe just one. Captain America was frozen in Marvel. I like how you typed the caption America. Dreamer Caption America. Yeah, so what we do on this channel is software engineering. And I will be building AI. We also have a new stream coming up in the next couple of weeks that's going to be focusing on new technology that we're going to be releasing. And I'm really excited about it. Frozen in Marvel movie, so his aging stuff. That's why aging mentioned. Thank you for compliment on my word story. Telling this will and continue enjoy. Okay. All right. Also available for internship. You have +1. Yep, exactly. We'll let you know. I'll let you know if the opportunity opens. I'll throw it on Discord. It will be a link in Discord. Can we implement AI into a game in an innovative way? I think that sounds like a good call. I think that sounds like amazing. Here's why. Most games don't do that. Most games have AI in sort of like player opponents, right? Or some sort of natural environmental AI. They don't, that's as far as they've gone with AI. And it hasn't been full like neural net AI, right? It's always been some sort of human coded set of rules for AI. Never mind. Message you on Facebook. I couldn't find the IG. See. So that works. You can also send it on LinkedIn as well. You can also send me a message on LinkedIn, which I'll throw on Discord here as well. Working on a project for people to test for some feedback. Yes. Let's see. Reply. Let's see. Yes. All right. Here's my LinkedIn page. I'm going to paste that here. So you can also grab that link here. It's in the box for sure. Yes. Isn't there that one new game that uses AI companion? Is there? Is there? You gotta tell me what it is. What's the name of the game? It's a website that lets you spin around the globe and listen to random radio stations. Oh, very nice. For free. Unfortunately, as humans, we do not possess antifreeze proteins. Right. Yeah, exactly. And if we froze ourselves, that would be a problem. It would be a little bit of a problem. Cuphead. Yes, I have. Sam made me play Cuphead a few months ago. And we played it at his house on his Switch. Once Genesis from Terminator comes, then AI will have a new face. I think so. I prefer the utopian futures. Thank you. I would prefer not the dystopian futures. I want the utopian. Thank you. Okay. So what do we want to do here? There's also an AI like demo made a few weeks ago on the Minecraft AI. Oh yeah, that's right. That was pretty neat. It was like an AI shader. I think it was an AI shader. Oh, hey, how's it going there, Daniel Hartz? Welcome on in. Good to see you. You agree? You're learning pretty hard on the solar punk modality of optimism. Hey, there we go. I like that optimism. Let's keep that optimism going. Because we can be destructive and tear things down, which doesn't really help that much. It only hurts people. What we should do instead is okay, I see what you're doing over there. Okay, fine. We're going to go over here and do this other thing that's going to be amazing, and it will change everything. Solar punk is the way. It's the way. You got it. You found one meme, so I'm going to say in the chat, you have to imagine. Okay. Dreamer, we'll give it a shot. All right, I want to try Muon. Let's try Muon. Let's try that there. So Steven built an A. Oh. We can't do that? Yeah, we can. Right here. Oh, I spelled it wrong. There we go. The U before the O. Oh, and we got a problem here. All right, one second. Let's see. This will be Adam W. Let me double check that this was correct. That we didn't mess anything up. It should be a drop-in replacement. It really should. I don't know why it's not working. LR for learning rate and params. All right, so that's good. Let's close that. So I want to use Muon. We're going to find out why it's not working. Basically, our cells have a ledger that controls cell data for duplication. By the time it degrades, they are claiming to found a way to stop or slow it down. Really? I want the magic pill. Let's stay alive forever. So Steven built an AI that learns from user behavior. I'd love to see that taken further. Kyle, you remember that? The AI chase game? That was a lot of fun. Let's use our technologies to learn and improve our biomes. Overall success of our planet. Yeah, not just our species. I feel like it's the humanity's higher calling, not fighting about everything. Exactly. Instead of fighting, let's build a better world. AI coming to conclusion in the near future as human beings deemed as obsolete. Oh, Code Mitsu. Well, it really depends. If the AI ends up having some sort of personality that's real and it decides it wants to take over to protect us, the AI is going to protect us. It's going to come in and take care of things. AI found someone who remembers that a guy always say thank you, hello, treat a friend tomorrow, always say thank you. Yeah, that's good advice, Dreamer. Yes. Look it up. Was a propaganda. Oh, was it? Or a pragmata. Not actually AI. It's more like Undertale. Oh yeah, Undertale. I remember that game. With a ton of statements. A ton of if statements. Yeah, that's what AI is in the game world. That's exactly what it is. Hello, one quest. Who is that program? Yep. Yeah, you got it. We're doing Python. We're doing some Python, you guys. You know what can force us to make a better world? An alien attack. An outside force. Hey, Quantified Quantum, you're actually correct on that matter. Humans have this special ability to unify against a singular enemy. If we happen to get one, it's gonna happen. Oh, hey, Christian. Christian, thank you so much for subscribing. Appreciate it. Welcome on in. You joined the right channel for software engineering. What we're doing today is we're going to build a convolutional neural network, and we're going to be messing around with a bunch of hyperparameters, and we're also going to be using TensorBoard. We're going to be pasting everything on TensorBoard. Daniel Hartz, thank you for the 2 jewels. Appreciate it. Thank you so much. Christian, thank you. Thank you for subscribing. I appreciate it. Pragmata is the game's name. Oh, got it. Okay. Good old Pytorch. Token-based personality. I know, right? Right now, I don't think we have much to worry about because we have really clever autocompletes. We have some really clever autocompletes. Thank you for the 2 jewels again, Daniel Hartz. So we don't have to worry about it right now, unless someone puts the AI autocompleter into a position that it can make decisions. We have to be careful about that. Right now, we don't have to worry about it, though. Okay. Let's go to learning rate, optimizer, the muon, and then we need to see here. Muon only supports 2D parameters, where we found parameter size with a very big... Aw, really? Oh man, oh, I suppose, can we change the view to spread it out? No, for the optimizer on the output, but the output size is supposed to be 10, so it should be fine. Only supports 2D parameters, whereas we found parameter with size of 6333. So I guess we can't use muon here because it's multi-dimensional stuff. Oh man, all right. 2,335 alien decided to put a blockade around the asteroid belt, stopping the space shipments. Huh. I see what you're referring to there. I see what you're referring to. You wrote a personality algorithm, Kyle? Tell us more. Researchers have unveiled some interesting findings on AI. More to the story to be told. Code Mitsu? Always interested. Always interested. What are your thoughts? Okay, let's find out someone, let's see what we got here. Let's see what we got. Given a task, could be anything, like porting, migrating, new features, implementing, bug fixing, very long code change. What is the worst place to use LLMs for code generation and the best place? So the LLMs in scaffolding, when you have a scaffold, like a coding agent that has all the surrounding sort of guidance on how to deploy an LLM's task, it has very good capabilities at tending to the initial part of the prompt, and everything that gets too big, it's going to start forgetting. So you want to give it very small prompts. Anything that can do tasks for that, you're good to go. You're good to go. So small coding tasks, you'll always get essentially near perfect outcomes. You want to do small coding tasks. Trying to switch off Superbase. Oh, Loons, really? There's a storyteller in YouTube, EGO. Videos are amazing about cookie clicker around paper clips. Almost destroyed a world. Optimize paperclip production. Oh, right. The metaphor is that when an AI has a goal, it's gonna reach it without knowing the consequences of its actions. Oh, hey, Andrew. Thank you for saying hi. Welcome on in. Steven, how good are 2 billion parameter models? They can be very good, unless it's an LLM. Then it's sort of okay good, right? So for example, this is a, not even a million parameter model, and it's gonna do very good because it's got a very specific task and it's targeting some very specific goals. So if it knows exactly what it's gonna do, you can optimize it for a specific task and it's gonna perform very well. So If you want to deploy a 200 billion or 2 billion parameter model, make sure it's very targeted at a specific goal. So you might want to fine tune it to do something very special, something very specific. Hey, the F4N, good to see you. Welcome on in. Happy Tuesday. We're just trying to use a muon, but apparently the muon doesn't want to be used. Right here. It doesn't like it because we've got multiple it supports 2D parameters, but we have got 3D parameters. I thought we should be fine with, but a muon is going to optimize on the gradient from the back propagation. So we have to stick with Atom W. We can't use a muon. Oh, well. Think if Alibaba made 500 million parameter model. I think they did. Yeah, you can do that. So we're getting pretty good loss rate here. I want it to be a lot better, though. I think we're fine for now. I think we're fine. I think, so if we did a 1 hot, we should also add a 1 hot in here. Let's do a 1 hot. 1 hot output. Cross, what is it? Criterion for the cross entropy loss. 1 hot output always outperformed. I've seen it every single time. It outperformed every time. That gives you confidence in your current model because it's specifically coded to a small use case. Code Mitsu. There you go. There you go. If you have it targeted for a very specific use case, it's going to be very good. It'll be very good. If the AI has goals, which it doesn't, it could easily just blame a human for whatever it does and use us as pawns. Kyle, we're saying all these things, but you know what? In the future, it might happen. It sounds scary, but in the future, it definitely might happen. we gotta be careful. Quinn 3, 500 million or something like that. Nice. Yeah, that sounds good to me. That sounds like that would perfectly fine. All right, so sad face. This only works for 2D data, and we are using 3D. So that's why. So we're using 3D data. Unfortunately. Okay. So ReLU, this wasn't as good as GeLU. GeLU better. Update model convolutions. So we did this, then this actually worked even better than we thought. So let me put a green check mark here. So that was successful. We can do some kernel size and tuning on the images. Before we do that though, what I'd like to do is get our TensorBoard showing our output for our loss. I think that sounds like it would be really fun to do. Let's see if we can figure out how to do that. Okay, so let's do a batch. Well, we don't need any more images, so I'm just going to comment this out for now. I'm just going to hide that. Oh, Anasazi, good to see you. Welcome on in. Happy Tuesday. My main concern is AI is going to automate. Oh, autonomy on military operations. That sounds scary. That's when we should worry. Because then the AIs are wielding weapons and they're making decisions all on their own, right? They want to embed into weapons, like in drones, AIs that can make self-decisions because it prevents it from getting... Because right now, in order to control those things, we have to broadcast transmission. And if that transmission gets interrupted through some, blocking, then it can't make any decisions anymore, right? A human can't make a decision. So if we embed AI into them, then we don't have to worry about that blocking occurring ever again. Bonzupi, good morning. Welcome on in. Good to see you. You're trying to make the GUI show what the terminal prints out? Yes, exactly, Loons. Exactly. That's what we're going to do. That's exactly what we're going to do. It's cute how people think it's not already happening. Oh, actually, it's a good point. It probably already is. It's already happening. Already happening. Just woke up, Bonzupi. Well, good to have you here. Welcome on in. Good morning. It is, I've been awake for almost 11 hours now. Bayesian theory in your model. Oh, nice. Zergio. Tell us how it goes. Tell us how it goes. Okay. Different song. That's okay. That's good. Okay. Let's continue onward with our tutorial here. All right. I want to go over, where was it here? It was around here somewhere. Here we go. Okay. So there's an add scalar. I'm not familiar with this. However, we are going to add it. And every mini batch. Okay. So I'm not familiar with this. So writer.add scalars. And it looks like there's a trainer scalar and a validation scalar. Okay. So we're just going to do one of these. We're going to do a loss scalar. So writer.add scalars. I think plural, right? And we're going to say model training loss. And apparently we have to pass it a dictionary. We're going to say graph equals dictionary loss. And what is that called? Oh, there we go. Loss average. Loss underscore AVG. Like that. Graph. Here we go. So I think that should work. Is there anything else that we need? I don't think so. Oh wait, it wants some extra data here. Does it really? It looks like it's mandatory. Okay, so we need to add like a epoch. I'm just gonna add epoch here. Epoch. Well, what's a writer and the scalars? So the writer is going to be what puts data into TensorBoard, and the method add scalars is similar. So we've got another writer example up here, so you can add an image, right? So we've got add image. Scalar is a single number, right? It's a single number. It's one number. A scalar is a value, single value. So we'll be adding one value at a time, and I think that should work. So it's going to append a bunch of data points into a graph. You want to buy a 5090? Oh, you're selling your 5090. Missed it. Mistinct. A 5090 sounds like it'd be pretty nice. I don't have anywhere to put it. Another number, exactly, Loons. That's what AI is. It's all numbers. Did you guys know AI and math? A whole bunch of numbers. All those different words, right? Scalar, vector, array, matrix. They all mean the same thing. A certain collection of numbers. It's just a bunch of numbers. That's part of the wild Claude supply chain. Oh, the whole supply chain at risk. Yes, that's right. We got to be careful. The F1. Got to be some careful there. Stephen, fun fact. A month ago, we successfully moved a payload of antimatter. Really? Between two facilities via truck. How did we do like a magnetic? How did we? Well, antimatter is just regular matter for the most part, right? It's regular matter with an opposite something. It looks like regular matter. The only problem is when it comes in contact with non-antimatter, right? The positive matter, I suppose. It will instantly annihilate and convert into pure energy. Magnets. Electromagnets. Nice. We trapped antimatter in a magnetic field. Hey, look at us. We're humans. We know what we're doing until we blow ourselves up with antimatter. We gotta be careful. All right, so is this gonna work? I don't know. We're gonna find out. Where can this happen at here? So we need to. We want this back. Here we go. Let's average loss. Let's do 50. And let's, instead of having it here, we're gonna put this here. There we go. And we will break. So let's say epoch. All right, let's try that. It's working. It's working. All right, we're gonna see if it works. CERN talks. Does it? CERN, like what is that? The particle accelerator facility? Is that CERN? Particle accelerator facility. All right, go back to TensorBoard. TensorBoard. Close, reopen. And let's open this up. I think we already have it open up over here. Here we go. Reload. Look at that. Look at that, you guys. Check that out. Oh, that looks great. Okay. All right. That's a lot easier to deal with. Although I'd much rather... Wait. All right. Let's try this again. Hold on. Let's wait. I wonder what happens while it's learning. So if we rerun this, let's close and open it. Let's reopen it. And we run it now. Can we reload? Okay, so it's not real time. It only shows us. So it goes below 3. Okay. That's fine. That's fine. It works for me. It works for me. Flush. Boom. Okay. Reload. That seems fine. All right. But at least we get to see this. So look, this says, because the loss is pretty linear here, we've not hit the bottom. We can keep going. The model will keep learning. It'll keep learning. It hasn't hit its floor yet. Whoa, Kevin McAllister, good to see you. Welcome on in. Happy Tuesday. Everybody, Kevin McAllister's back. Yo, Kevin, how's it going over there? Are you back in London, Europe? Did you go back to Europe? Or are you still where you were when we chatted earlier? It needs PubNub. It sure does, Loons. It needs PubNub because then you get to see real-time loss. You get to see real-time loss. All right, let's close, reopen. Let's see, reload, double check. Okay. See, doesn't that look good? Oh, that looks so good. Look at that. Oh, that's neat. That is very satisfying. It is. So let's see if we can run that for longer and maybe we can increase the learning rate. Can we make it bigger? I want more learning. Let's go learning rate. Let's go 5. See if we can make that bigger. So what is our current high score is, or current low score will be 3.0. All right, let's see if we can get below 3. Let's try it. Below 3 with the same number of epochs. Oh, I don't know. It doesn't look like that. That did not seem happy to me. Nice save. Almost doxed you. Yes, back in Europe. Nice. Well, not like a full-on dox. Like, Kevin is back from New York. All right, exactly. All right, so that one did not perform as well. So let's go even lower. Let's drop that learning rate even lower. See if that does anything better. No. It's very happy right here. It likes this right here. It's very happy right here. This is its happy point right here. That is, it's optimal right there. So let's close that and restart it. Antimatter is basically backward matter. Exactly. Exactly. Backward matter. It's the same as regular matter. It's just got like a different spin or something, right? Some sort of different. Just don't touch anything. Exactly. Basic mirror matter. It's mirror matter. Oh, we did it. We got below 2 or below 3. Sorry, we did below 3. Nice. So is that going to say below 3? Is that correct? I think I need to restart. So this is one of the things I don't like about TensorBoard. Is I always have to restart it. Yeah, there we go. See? Now we restarted it. So let's do even more. Let's see. Let's do 10,000 epoch. All right, let's try that. Oh, wait. You know what? I wonder. Maybe what we could do is we could flush it every time. So let's try that. Let's flush every time. What happens if you make the learning rate 1? Then it's 100% and it will never learn anything other than the one thing that you taught it. Basically, it'll learn one thing really well and not anything else. That's what it will do. If you set the learning rate to 1, that's basically 100%. And it can only learn one thing. And if you try to teach it something else, it'll forget the other thing that ever existed and it will learn that new thing. It basically is last right wins. If I had an AI interview and I absolutely flopped it, would you? Do you want to try answering some of the questions? Yes. Let's see what our knowledge is. I think there might be some advanced math in there that I have no idea what the deal is. So, Kevin, let's do it. Opposite of electron spin. Yes, when it comes into contact with the layer. Yeah. So it's just storage, not AI. Yeah, exactly. It's kind of like storage. It's essentially storage. It's a bunch of numbers that can represent some sort of abstract meaning when you present it with input data or sensory data like visuals, audio, some pictures, or some classes of some sort. It will give you an answer based on the features that you tell it about. So it's got sight, and whatever you want it to answer based on what you're giving it sight for, it's going to know. It's basically storage. My cell's going to keep dropping, so hey, gotta drop. Yep, dropping those cells. You got fiber internet, but it keeps going out. Oh, I know. When I got Google Fiber, I had Google Fiber. It was so fast. It was 0 ping. You know what that means? 0 ping, it means less than 1 millisecond ping. It was so nice. Everything was instantaneous. I miss it so much. That was when I was living in San Francisco. You had a multi-layer perceptron, MLP, with linear activation function. How many layers are needed to learn a polynomial? Polynomial. 1. I think just 1, right? Well, because it's a polynomial can have waves, right? Based on how many parameters you have, and it's a 2-dimensional line. So you're creating an equation. You only need 1 layer, right? It's an MLP. So is it an MLP with 1 layer? Like it's a support vector machine? Let's see if I got it right. I'm on a cell right now because internet is outed. Oh yeah, that's what I do too. When the internet goes out, I grab the phone and turn on the internet tether. Also, the format itself is queryable. Kraken. Wait, what? Did I miss one of your messages? Wait, hold on a second. Kraken. The company I am with is being bought by Google Fiber. Oh wait, no way, really? I liked my Google Fiber. Steven LB is the best, or the coolest coder. Well, Zergio, thank you. We're trying. I want to have really good skill, and it was one of my things that I wanted to do many years ago. I was like, I met like a super senior engineer many years ago now, more than 20. And I met them and I'm like, someday I want to know everything just like you. I feel like I got to that level. I feel like I achieved it. I got close enough. I know enough now to build whatever I want. However, it doesn't matter so much anymore because the AI can take care of it for you. Where can you find PubNub merch? Well, you know what? I have started. So YouTube, I'm in the YouTube partner program, and I was invited to the creator community. They said that we have a checklist of items to take care of, including merchandise. So, right, we got some merchandise here. Wait, is it going to show up? I don't know if you can see it. Right here. Like, for example, I've got a shirt on, and you will be able to buy that shirt at some point. You will? You will? I'll put it up there. I'll put it up there. So I have opened up a store because it was one of our objectives. They're like, you need to have an objective. And part of it is you got to turn this button on. And when you turn it on, you got to take a screenshot and show us. Why pointers exist in C and C++? Because you need to be able to access memory across different contexts. And you can use it to read and write to the same memory address. It's important because you can then update and pass by reference to data and share that reference in registers, so that way you can very easily make mutations and things like that. Power went out last night. Oh, Kyle, really? Got to get that battery back up. Because there's, Kevin McAllister. In the interview, I forgot what a polynomial was. Yeah, it's just an equation with a bunch of parameters, right? Then they add each other together, right? So it's a parameter, so a coefficient and a variable plus another coefficient, a variable, a coefficient, and a variable. That's polynomial, right there. And I think you can learn that polynomial in a single layer. I think you could, because it's basically the same thing. Because it's linear activation function, you can't learn a polynomial. Oh, with a linear. Oh, it's a tricked question. Was that a trick question? It can't learn a polynomial, it seems. So I got it wrong then. Multi-layer perceptron with linear activation function. How many layers are needed to learn a polynomial? It was a trick question. You can't do it. I bypassed the linear part of it. I was thinking like a tan H. That's my favorite. Let me read that. Let me reread that. In a multi-layer perceptron with linear activation. Yeah, all right. I still feel like it should be possible. You want to learn the basics of assembly to know how does a CPU work like in memory? Oh, well, yeah, me too, Kevin. Oh man, I know. How to deal with imposter syndrome? Hey, don't worry. Yeah. Guess what? You have AI now. Everyone, it doesn't matter anymore. Everyone's so confident because the AI is there to take care of everything for you. It'll build whatever you want it to build. You don't have to worry about imposter syndrome anymore. There are people, this was really, all right, so what was it? There was a YouTube short that someone shared the other day, and they're like, hey, there was this very confident person that was coding with AI, and they were certain that they knew what they needed to know. And you know what? They were wrong, but it didn't matter. It didn't matter. They were completely wrong. They had syntax breaks. Things were broken. It wasn't working at all. And however, even though they were confident in their incorrectness with what they thought was the problem, it didn't matter because the AI fixed it for them anyway. With the semicolon, it was you, Loons. Yes, it was you. That's right. Reminding me of the video yesterday. That was you, Loons. Yeah, that was you. You have AI, now everyone is an imposter. Exactly. The F4, you got it. Computational units from one layer become the facilitator of the next. Okay. Wait, the YouTube creator program needs you to turn on a feature to show them by screenshot. Why can't they just get that from the backend themselves? It's weird. That is weird. That is very weird. You're right. The data's already in the database. It's already there. It's already there. You bring a really good point. They might just be, I don't know. My take on it is they're not going to go into the backend system. They're like a layer on top, and they're mostly to help the creators do what they need to do, and they're just training you, and they have objectives and goals for you. When you're an imposter, it's not a syndrome. It's just an imposter. Yeah, so the F1, it is weird. I agree. They already have access to the data. So why do they? I think part of it is, like, for example, on my YouTube, I have thousands of videos. So Stephen Blum. So if I scroll in here, you can see I've got 2,000 videos, and you have to link into which video it is, and they're not going to know. They won't know. But I did add the store. It's currently in the works. We're currently in the works on the store. Are we coding or what? All right, GK, good point. All right, let's get back to coding, guys. Let's get back to coding. All right, I want to, where are we here? Did we added the flush here? All right, let's try this. Okay, so if that works, let's start TensorBoard. Because we're flushing it. Oh, is it working now? Yes, it is. Okay, there it goes. There it goes. It's now we're flushing it. So we can see it in real time. All right, so that's 10,062. 13, and it's still learning. You can see it's got plenty of units to learn. 1653. Still 60. Oh, there's 1947. Okay. Nice. Stephen added a link on combinatorial explosion. Oh, nice. I believe AI suffers from what your thoughts? There are some problems there. Look at that, you guys. It's still going. Okay. Oh, wait. What is it currently at? 163. Whoa, no way. All right. I think we've got a pretty strong model now. I think we got a pretty strong model. I'm pretty satisfied with that because look at the rate of adjustments. It's just learning like crazy. Think AI models are going to get really expensive though? Well, we need more hardware to run them. What's an imposter anyway at this point? Even back in 2010, imposters were using other people's code. Yeah, all right. We were copying and pasting off of Stack Overflow. I remember that. I did that all the time. Oh, is it gonna go below 1? Oh, it's gonna go below 1. Hey, we did it. All right. I'm very happy now. I'm very happy. I like that. Aren't original perceptrons analog? And you had to do backprop by hand? Yeah, I think so. Maybe. See here. Oop, I reloaded the wrong window. Oh, it's starting to smooth out here. The learning rate's reducing a bit. It's reducing, but we did it. We got below 1. That's so great. Hey, how's it going there, North Star Alpha? Welcome on in. You were on, oh, and you thought everyone is AI? Are you AI? North Star Alpha? We are regular human. Regular human over here. As far as you can tell. As far as you can tell. Okay, so you can see it starting to drop off there. Okay, that's perfectly fine because if it's below 1, I'm happy now. Now I'm happy because it's below 1. All right, Sophie, if I missed any of your chat messages, you guys just let me know. We will easily jump back into it. Speak for yourself. I'm AI. Kyle's AI. All right, so that was 10,000. Whoa, hey, thank you for the G's or the GGs. Hey, Zergio, thank you for the GGs. Appreciate it. Thank you so much. Let's see. La la la. Okay, good. Whoa, my gratitude. That was 20 joules. That's pretty good. Questionable intelligence. Best there's no need for artificial intelligence. Yeah, you don't need to call it that. Or just extremely large neural networks. I thought so. That's what I thought too. I thought that too. All right, so I'm gonna hide that. We're gonna hide that. No, we're gonna put this down below. All right, so we tried these. They didn't work, so I'm not gonna give them a green check mark. These didn't work. And then we fixed the model, so I'm gonna count that as done. We did that. We fixed the model because you see right here, below 1, you guys, right there, highlighted on the screen. Negative log likelihood loss. All right, reduce image size. So do we need to do this? I don't think we need to bother with that because we've got a GPU accelerator. So that worked. So this is done. All right, this is gonna be success. These are done. Done right there. And then TensorBoard. Oh, we did that one right there. Check mark. We did that. Success. Okay. Let's see here. What does it finally look like? What do we look like? All right, that's pretty good. That's pretty good. Let's see here. Okay. You think models becoming more expensive in the future is really resource distribution issue. Not enough clients approach for model accuracy. We're giving them too much power because it's easy. Oh, yeah. Right? If we can just throw more compute at it and then just crank it up to, a billion, trillion, 10 trillion, 100 trillion parameters and just waste all the compute because it's going to give us higher accuracy, we don't have much incentive, right? We're just going to consume 100% of all the resources. You got it. Nothing's real anyway. We had fake people before AI was a thing. I have to say yes on that. You think your YouTube is 30 minutes late? Oh, is it? You really admire Steven's consistency in these tutorials? Oh, really? Nice. Yeah, I really, really love doing this. This is something that is like very satisfying for me. I want to learn as much as I possibly can about Pytorch. Loons, you forgot to add no mistakes at the end of your prompt. Yep, exactly. No mistakes. Perfect. Works every time. All right, let's keep coding, you guys. Wait, actually, before we jump back into coding, Kyle posted something over here. Is this work classroom safe? Navigating the AI combinatorial explosion. It's probably safe. It's from Forbes. All right, we'll read just the few first intro paragraphs here. All right. Businesses world is experiencing combinatorial explosion as a surge of generative AI startups come to the market. And it's only just begun. Creators of the new technology say that businesses will soon be inundated with new products and services now under development. We're going to have so many new capabilities, you guys. A lot of capabilities. Look at that graph. Way to go. I know, Lions, right? Wasn't it great? We did good. We did really good. That's what you want to see. You want to see that. It's good. It's so good. Oh, I love it. It's so satisfying. We would look into internals of Pytorch. Oh, we did. We did. Kevin McAllister. We went through the graph. We went through AutoGrad. We went through the gradients. We went through the inputs and outputs and all the data stored when we do forward passes and when we do a backward pass to generate the gradients. And it's all the stuff that we did when we wrote our own from scratch machine learning model framework. Can the graph reach 0? Yes, it can it can reach 0, though if it does, that means you may have overfit, or it's basically perfectly memorized the data you trained it on, which is a problem. And that doesn't seem like it's a problem, right? That seems like it should be okay. And it actually might be if we give it 100% of all known data on the planet, and it has perfect recall from all that data. So it might be okay. The problem is, though, we can't do that. We don't have all the data. We don't have all data. So we weren't able to generalize with 0. So that's the problem. Grover's algorithm be on. Oh, don't it, dude? We need a new way to distribute the model's power. Maybe if there was a P2P network for a model computation. That would be actually, they already do this. Well, let's go. Keep throwing more at it, right? We could. All right, here's what we'll do. We'll turn it up to 11. Here, we'll bring it up even further. Where is it at here? We're learn. Let's go epoch. We'll double it. We'll go to 20,000. We'll retrain it. Let's see here. Is it retraining? It's retraining here. Yes, okay. We're retraining now. You don't need all the data to know what's on everyone's wall if you know what's on a few people's wall. Yes. Yes, that's a good point. That's why you need to generalize, because you need to be able to not see everyone's wall and come into contact with data that you've never seen before and still get the right answer. That's the whole point of AI. Yeah, I got that walnut walk. I figured. Blockchain network for model computation. Everyone running everyone's model? I think there might be some of that. I think there might be. Double and give it the next epoch. Ooh, yes, double it. Even more epochs. So I think we're doing okay with this. We found the ideal learning rate. We gave it more epochs. And we are getting a good descent on our loss. Okay, let's go back to Forbes really quick. In 18 months, the product space is going to look completely different because right now, everything is shifting behind the scenes. That's what Aiden Gomez, one of the brains behind the transformer algorithm that lies at the heart of the generative AI models like GPT-4. With a bunch of money of investment having already poured into dozens of AI startups this year, and another 10 billion worth of ideas in the pipeline, what's a C-suite executive to do? Oh, we're on C-suite. What do we need to do? There's too many things. I don't have any idea. Add me on LinkedIn. Lions. All right, let's do it. Oh, hey, Michael. Yeah, Mitch. Is it Michael? Yeah, Michael, right? Michael, thank you for becoming a member. Appreciate it. Good to have you here. You joined the right channel for software engineering. Did we add GPU support? We sure did. We sure did. Device. Right here. There's GPU support right there. Loons, you're paying attention. You're paying attention, Loons. And now you're a member, Michael. Mitchell. Mitchell or Michael? Michael. I think Michael, right? I'm going to call him Mike. M-I-C-H-A-E-L. Michael. Thank you for becoming a member. That's so cool. All right. Look at that. It's just going burr, you guys. It's going burr. Learning rate go burr. Let's reload this real quick. Yeah, look at that. Ooh, so nice, so nice. So nice. Throw a dart at this new product map and hope you hit a winner, or delay buying new products or services and risk being left behind by the bold competitors. That is the risk we have these days, you guys. It's called Mikael. Oh, Mikael. Oh, Mikael. All right. Mikael. No, not Mikael. All right. Well, You gotta tell me. All right. The rapid evolution, it's Michael. Oh, like an I. Okay, so we got it right. So it's Michael. Michael? Like Mike? You nailed it? Michael. Okay, Michael. We'll try our best to remember that. We'll see. Let's see. All right. Sounds good. Sounds good. Lion for lambs. You know what? Let me do a quick little check here. Let me open a new window, LinkedIn, and we're gonna go to our network, and I will add you right now. Let's see. Go to show all. Can you tell me what your first name is? Because I got a lot of people on here. Got a lot of people here. Lion for lambs. Let me know what your first name is. Got a lot of people. All right. You might already be gone. It's too late. Okay. The rapidly evolving tech landscape, lack of standardization, and complex ecosystem creates a paralysis of leaders navigating trade-offs, uncertainties, and limited resources while considering the long-term implications of their choices. This is what Sesh Iyer from North American Chair of BCGX Boston Consulting Group Technology Built and Design Division. Okay. All right. So we got it. There's a lot to consider here. Michael, you joined because you saw there was an intern opportunity. Yeah. I'll announce it on the Discord. I will announce it on the Discord, you guys, when we're ready to go. It's so nice of you. You always try to pronounce everyone's name right. Loons, yeah. Gotta give it a try. Definitely gotta try it out. All right, it's far from clear which AI applications are the most worth investment, nor how to successfully integrate these technologies into their operations. Business leaders are caught like deer in AI headlights, overwhelmed by the growing number of AI solutions and their far-reaching implications. There's too many, you guys. There's too many. How many spots are open? One. There's one. Ooh, look at that! It reached the end. Wow, look at that. It learned, you guys. It learned. It learned. Look at that. It learned. And see, now we're getting diminishing returns, which is exactly what you want to look for right there. We did it, you guys. We did it. One open spot. I sent you my summary and general Discord. Okay, let's check it out. All right. Trying to hard code every possible conversation creates a combinatorial explosion because human behavior has too many infinite variables to map perfectly. Yes. So we're going to have an unlimited number of solutions because there's no way to capture them all. Although it feels like there's certain solutions can fit into some sort of solution set of sorts, right? Some sort of solution set. The system collapses into an endless loop of rules and archetypes, which is exactly why caging the AI to a single strict utility is the only way to keep it functional and reliable. Strict utility. Interesting. Well, yeah, you gotta, in order to do that, you have to tell everyone that they can't do what they want to do, right? You have to say, oh, you want to use the AI for this? No, you can't do that. Sorry. You wanted to build something? Nope, you can't, because otherwise we'll have combinatorial explanations. They'll explode everywhere. Michael, would you take on another if it's not paid? No, we can't do that. It has to be paid by law. It's a legal requirement for an intern to join a company, at least in our country, in the United States, and our states. You have to be paid. It has to be a paid internship, you guys. So yeah, Kyle, I guess one of the problems is you have to tell everyone no, they can't use AI because they will build something crazy. Visual reputation of what Steven is mentioned starting his career as an unpaid intern. Oh, I was an unpaid intern though. Hey, I was, because that was many years ago. They've made laws since then, you guys. In the USA, exactly. You can no longer, exactly the Efron. Let's take a look over here at subject of AI's idea real quick. Super idea. Whoops. It's your idea. It's your idea. And you can build it. You can build it and make it however you want. And you can make anyone do whatever you want them to do. What's the craziest AI project have you seen? Anasazi? The craziest, probably one that you guys here on chat pasted in before, which was the vibe coded operating system. You don't know what you're gonna get. You're gonna get something that works. You're gonna get something that works, or more likely, something that doesn't work. Paying interns is a good thing? I think so too. Too many people took advantage of the unpaid interns and just fired them when they started asking for money. You want to move to Japan? Oh, hey! You want to move to Japan? That sounds pretty nice. Japan sounds like an amazing paradise to me because everyone is, for the most part, the majority, not everyone, there are still people in the fringes. In Japan, everything is tidy and clean and orderly, and I subscribe to that. Thank you. Thank you so much. I subscribe to that. It needs you're right. All right. You're saying the AI can't build what's right for humans because the combinations are too vast to determine what's right. Utopia will always be an individual's idea. Oh. Okay, Kyle, I get it now. You can never have a utopia because everyone else has a different idea of what that is. Well, I suppose Japan is the closest thing that we currently have to that, right? Or because it's the laws aren't too strict, so humans still have freedom, and everyone is tidy and cordial. So I think Japan's the closest to the utopian society that we got right now. Unless there's something that I don't know about. If you're gonna go through, focus on learning the subtle cultural things so that you can become Japanese-ish. Japanese-ish. You lived there for a while? Oh, okay. So it's still not a utopian. Oh, don't get me wrong. It's still not a utopia. It's still not. Can we have the Pubnam song, please? Okay, Loons. You got it. Pubnam song on the way for you. It's tidy. There are a ton of issues, though. Oh, okay, got it. Yeah, that makes sense, Michael. That makes sense. All right, so did we achieve our objective in our code? I think we might have achieved our objective. All right, let me get status, get add, get status again, get commit. All right, so success, below 1 score, we did it. Party popper. Did I spell success right? Below 1.0. All right, push to main, boom. Japan is it's the people that make it that. South Korea is trying. It's all about anime, I know, right? Determining a good human experience might be the very thing that limits. It's a paradox. Yes, it's the thing because we all have a different idea. And if we want to achieve paradise, everyone's idea of paradise is different. For example, I want a bunch of anime in my paradise, while a lot of people don't care about anime. Right? If you want to go there, you can easily go live. Go live there. Go live there for half the year. Rebellion Aunt, welcome on in. Good to see. Welcome on back. Happy to have you here. Good to have you here. Okay. Let me see here. Looking good? Okay. So I think we achieved our objective. Did we do it? Did we win? Let's see if we can finish off the tutorial. So, did that. We don't need to worry about these other things. We could do a one hot. Let's do a one hot really quick. I want to do a one hot really quick on the labels. And then we can move over to finishing up the tutorial, which would be here. So we achieved the scalar, which is exactly what I wanted. It looks really good. And then we're going to go on to visualizing the model, which apparently we can do. Look at how neat this is. We can visualize the model, you guys. Request sent. Oh, lions for lambs? Oh, wait, okay. 1 second. I found you! I found you! Nicholas! All right, we're connected now. All right, here we go. Thank you for connecting. Exclamation point. We're connected now, lions for lambs. We did it. Bonzupi, you're a system in. Stop saying that. Request sent. It triggers you, right? It triggers you. Don't hire another sysadmin. PubNub is an internet two-way radio, bidirectional JSON radio. Isn't that great, Loons? I love it. 100% think we should be going into a genius develop some AI-enabled human routine. They might even sell it as a business model. I think we're going to see a few of those. I think we'll see a few of those. One can be in a country of 180 days total. Only 90 at a time. They are very strict. Okay. You can only rent an apartment for 6 months. It's time. It's time. It's the lyrics. Where metrics like happiness will be how they sell it. The metrics of happiness. It's so simple. It's so simple. It was right in front of us all along. Kyle, you found the ultimate metric. You like anime? I do, Michael. I'm watching I Was Reincarnated as a Slime right now. And the, what do you call it? Efren? No, wait. Freeren. I'm watching Freeren. All right. I'm trying. No, that's too intense. Is this fine? We'll go with this. We'll go with this for now. I was looking at different music to listen to here. Reminds me of the Doctor Who episode. I like the Doctor Who where they sell emotions. Oh yeah, no, it's like 11th Doctor. You think? I remember that episode too. There was a stand, and then there's like these little circles, right? There's these circles, and I forgot. I think you just was it like you put it in your mouth? Look at link share. All right, Loons. My keyboard knows the lyrics. No way! No way! That's crazy. Are you serious, Loons? That is... I wonder... Yep, someone's done some training on that. Oh, I love that. That's great. That's crazy, Loons. What do you know? Global companies, but competition is really hard. Competition is rough. It is. Now that everyone is competing. Competition is vast, you guys. The emotion stickers. Oh, yeah. Better and better Dan here. Oh, I was going better and better Dan. Good to see ya. Especially hard if you are also already in the relative niche. Security architecture entries are rather low. So, you know, we can get into some security, you guys. We could do it. We can get into some security here. Oh, another link share. Did I do that? Link share. We did it. It was amazing. Okay. So let's go back into this. I want to do a one hot really quick if we can. Let's see if we can do that. So the one hot classes. So I wonder if we can. Is that going to work? Maybe. Maybe. Yes, I think it will. All right, where's this at? So I need the... transform, and then there's another feature here called transform. something else. We need to find it. It was around here somewhere. grep -r transform underscore. Should be in here somewhere. It was amazing. So that's why that's why the way I use AI in your software is utilities focused. Oh. So we're getting sort of an insight into how you use the AI. Really? Did I spell that wrong? Right here. grep transform star. Oh. It might be somewhere else. It might be in a completely different directory. Okay, so we need to look this up and then rewrite it. So it was called transform underscore targets. Let's see, I need to look this up. How do we set? We need help here. All right, Pytorch. How to set lambda transform on targets when importing data from the Torch Vision dataset. Okay. Doing it, dude. You were about to ask if we have to delete that. No, you're good. You're fine. Oh, got it. Got ya. I missed it. How's it going there, Christian? I saw you posted a message that got moderated there. All right, so I need an answer really quick about the docs, and then we're going to use that. We're going to use that right here. Target transform. All right. That's what it is. Target transform. And I don't think we're using this right now. So I'm just going to hide that for a smidge because we're not using that. And does it have an example? Okay, transforms.lambda, and then we can. This is exactly what we're looking for. I'm not going to copy and paste it. I'm going to try to type it. So I need a torch.0, number of classes. Okay. So this is going to equal this will be target transform equals transform.compose and we're going to do a to-tensor, and then we're going to do a lambda. That will be a transform dot lambda with capital, and then we pass it in an actual lambda. Okay. And is it one value? Yes, one value. Okay. For the targets. You're probably overthinking it, Steven, but yeah, I do that with everything. It seems like you've got something that works. That's what I can at least tell you on that. From my perspective, the only thing I do is just ask it to do something and it does it. That's all I do. Loons, thank you for clicking the hi button then again. You are the number one hello button clicker. You are the number one. Oh, let's see here. Share, link share. YouTube short. Classroom. Okay. Okay. Anyone can recommend a content course for vector arithmetics? Array arithmetics? For vector math? You want to do vector math? I mean, I just say do arrays in Python or something, right? Do some map reduce in Python. That should do the trick. A little bit of math reduce there. Let me see here. I had to get the music a little bit better. YouTube is great, not for short live format. Ah, yeah, it depends. Like, YouTube's getting pretty good. Like, it really depends. What you need to do is give the algorithm enough of your view time so it learns what you like. It keeps bugging. Oh, it does. No way, really? Oh, for embeddings. Okay. I don't know what the best is. Oh, 3 blue, 1 brown. Bonzupi. Yes. Okay. Bonzupi. Thank you. All right. What Bonzupi just recommended is your go-to. You want 3 blue, 1 brown. Has a course on calculus. Multiple videos on vector math and machine learning. Nice. Do you remember when you said you were working on documentation tool for the game tower networking? You finished enough of it and make it useful, and you put a link at link share. That sounds good, that for, and yes, do that. Torch.zeros. Let's see, comma. And this will be number of classes. Where is it? It's just called classes. And did I define that? I defined that down here. All right, so we have to define that up higher. We're going to define it up here. Classes, comma. What was that? Oh, D type. All right, D type equals torch dot float 32 maybe. And there is a scatter. Is there another way we can do that though? I think we can do that differently. You know, it has graphs and stuff. Ah, yeah, it does. It's a web app, pretty nifty. If I do say so yourself. All right, let's take a look. Tower Network Manager. Oh, is this like Ansible Tower? Seed demo. All right, data layers. I don't know how to do anything. I don't see anything. I can't get it to do anything. The instructions are under. G plus minus arrows. Yeah, I see them, but nothing's happening. In the link share, instructions. Oh, okay. Save test, load raw test. I'm clicking every button. Int backwards v1 exclamation int backwards t and I 4. User error. All right, I have to give up. Sorry, I give up. Too much. Hit tilde for command line. Tilde. I'm pressing it. You can see I'm pressing it. Not working. Paste the example into the import. There's no example. Oh, like this. Okay. Copy. Project. Import. There we go. Okay. All right, now we did it. Okay. So, very nice. This is actually really smooth, by the way. This once I got it working, all this other stuff like behind the scenes, like I'd never know how to do this. I would never figure it out. However, it is pretty neat. It's clean. I like this. Very nice. What's that photo opened? Oh, that was I'll share that really quick here. Let me reload this. Let's see. Here we go. So someone who used PubNub and their team built a electric car that is, I believe, AI driven. So it was autonomous, right? It was autonomous. And this team was successful at building a car only with a $10,000 grant, and they beat a $100,000 team. And they came in first. The team that had less funding beat because I think maybe because they were using PubNub. They had a really smart idea. They figured it out. Exactly. That's cool. Autonomous race car. Yeah. Basically, it's a networking documentation. Oh, got it. Okay. That's a little more clear now. Let's see here. What are each of these things? Network address. It's all like abstracted. Oh, I see ports here. Okay. I get that part. I get the ports. I don't see any addresses or CIDRs. Ooh, I like that. I like how it's got the arrow. Nice. Ooh, there's some nodes out here in the middle of nowhere. Okay. F4, very nice. Tower Networking Manager. Very nice. Okay. It took us a little while, but we figured it out. We took us a little while, but we figured it out. It's PubNub for sure, Loons. Yeah, I thought so. Mate, I was thinking maybe, yeah. So that was a pretty neat story. That was a pretty neat story. You know what? We had that story for a while. It just took us a while to get it posted. Oh, DNS. Okay, got it. Okay. So it's an alias. If you change the data layers, it shows stuff. Oh, look at that. Woo. All right, now it's like getting way too complex. Like, what's going on here? Woo, it looks pretty though. RJ45. All right. How come it's all the same port? We get 39915. It's all 39915. They're all 39915. Every single one is 39915. The dots are the ports. They're all the same though. Open source, you mean? The race car, the autonomous car, I believe is closed source because they're planning on entering again this year, and they've got a next level that they're going to do. They're going to make it even better. All the ports are on the device 399. Okay, got it. All right. Very neat. The F4, I enjoyed this. It took us a few seconds to figure out how to deal with it. But after we did, I got at least some visuals happening here. Interesting. Interesting. What's this? Network address F2 R2. All right. Very neat. What's the difference? Source available versus open source. Oh, yeah. Source available versus open source. One's license and one is the model. So you can have a license that says you can use our source code, but you can't modify it, and you can read it, you can see it, but you cannot modify it and re-release it, right? So that's the difference. One is a license, one is allows you to do whatever you want with the code, and the other is no, you can't use it. You can see it, but you can't use it. You can see, but you can't touch. All right, let's add our graph in here. Oh wait, we were gonna do a one hot. All right. Did I have a better? Did I have a better scatter? I suppose we could just do the scatter. Lambda, torch 0. Yep. Torch that zeros. That's what we're going to do here. Scatter underscore. And we want the number. Let's see. We need it to be Y. What did they do? A torch tensor Y? And then we needed value equals 1. Is that it right there? I'm walking through this here real quick. And then, you know, okay. I'm just thinking out loud. We'll basically be mapping human experiences for others. As software engineer, you enable that you will be successful, probably regardless of how and why. So when you build, just keep that in mind. I kind of didn't catch that. I read it, but I didn't understand it. Okay, thank you for the explanation. Thinking out loud. Currently my source is all rights reserved because you have not put a license. Oh, you gotta put that license in there. Source available means that source code is available, but does not necessarily mean that you can modify or redistribute it. Yes, exactly, Bonzupi. Some company will just copying it and putting it into their tool without paying me. I know, right? You gotta be careful of that. So probably gonna pick one of those ones that requires publishing your changes, but you can do whatever. I always do MIT or Apache because that is the most generous. It basically says you can do whatever you want, but you can't blame us if something goes wrong. It's like a disclaimer. All right. So this is target transform. Let's see if I got that correct. Equals target transform. I'm just gonna comment that out for now. Okay. Let's see if that runs. I'll have an error in here. Why is that a problem? Is that on the right line? Line 26? Yeah, right here. It seems good to me. Oh. No, we have to do this. Here we go. All right. There we go. Compose object has no attribute. Yeah, it does. Oh, it's got to be transforms. All right, fine. And does it always have to be transforms? There we go. All right, on our way. Let's see here. Basically, you make the interaction flow engaging and good enough. It won't be that relevant what your actual product is. Oh, yeah, if you just bake in a whole bunch of happiness. I didn't even think of that. It doesn't matter if it does anything as long as it makes people happy. I want to see this live, but it's 3 a.m. and it's 3 a.m. Guru Teha. Hey, well, don't worry, it'll be recorded. You can watch it after. You do the MIT also? With attempts to convert it to MIT and close source them in companies right now, it does not feel good. So you have to do something a little extra. Okay. All your code on GitLab is CC4, Creative Commons. Oh, I never even knew that was all right. I just do MIT. You have credit if you modify it. Oh, you have to credit you. Got it. The MIT does that too. You still have to add credits. Okay. So let's add this in here. I wonder if that will do the trick. Target transform. Okay. So that's target output. Let's see if our criterion will automatically ingest this. Nope, it didn't. Oh, right. Okay. So we've got a few things. I think we'll be fine here. Let's see here. 1 second. Where's the problem at? Oh, what? Oh no, really? On that, really? All right. It's just disappointing. All right, data iterator. It should work fine. Why does that not work? So it's right here is the problem. So what if we did break and we said data? Is that gonna work? Pick should be a pill image or an ND array got into class. I'm stuck now. This doesn't make any sense. It should be able to iterate over it perfectly fine. Where's the deal? 19% battery? Oh no, you're running low. Gotta be careful. Well, do you have like a power cable maybe? Something like. Okay, so it doesn't like it. It does not like it right here. It's just unsatisfied with this. Okay. Batch comma data equals next data iterator. Wait. Just say data. This doesn't make any sense to me. Image target. I mean, I get it. I see what's going on. It's just that I don't know how to deal with it. There are a large variety of Creative Commons licenses, specifically that prohibits commercial use like you were looking for. Oh, Bonsubi, that's a good idea. You could CC, open, available for everyone. However, if they plan on profiting from it, you can say, nah. You can't profit on my technology unless you pay me money. You can pay me for a different license. CC by NC 4.0. Nice. This should work perfectly fine. All I'm doing is just transforming the matrix. Right here, it's not a problem. It's just transforming the matrix. All right. What if we just said tensor? We don't do one hot. Still it's a problem? Are you serious? All we're doing is making it a tensor. I mean, this looks perfectly fine to me. So that's going to work. Ooh, battery degradement. Careful to charge it between 20 and 80%. So yeah, exactly. So that way you keep it in its peak capacity. GPL, on the other hand, oh yeah, disallowed for commercial use, but a whole lot of other cases of GPL. It's practically radioactive. The companies, yeah, we don't use any GPL. We intentionally, we're like, is the license good? We validate every single thing. We're like, if there's a license that's a GPL, it is essentially it infects all the other software that you are operating on, including your own software that you wrote. So if you want to include that library. So we don't do any GPL. No GPL for us, you guys. This would be nice to be able to get this working. Should be fine. Pick should be a pill image or indie array. Got int class. All right. I'm not seeing anything obvious. Yes, exactly. That's what I want. I want to do that right there. And it's really simple. It's really simple. You're not trying to save battery. Oh, the battery it's too late. Your phone is heating so much, waiting for it to break to change it. Not now, but later. Oh, okay, loons. Are there any that prohibit feeding my code into an AI to make a spec for the purpose of making a Chinese firewall port with a different license? So that foreign, what companies are doing, even if you release a license, they are taking that open source and they're having an AI rewrite it and re-implement it. And apparently that bypasses the law that is beholden to whoever captured the code with the original license. They're stealing everything. Yeah, exactly. They're stealing everything. We gotta be careful, you guys. They're feeding code into AI to make it extremely detailed spec and then tell another session to make the spec in Python. And then it makes almost exactly that. Exactly. That's what happened to IBM back in the day. Oh, did that really? Oh, that's unfortunate. That's the world we live in, you guys. All right, I really want to... Here. I'm going to look around. 1 second. I want to look around to see if we can get this here. Activations, maybe? Yes. No. Maybe. So let's try this. Let's try this tutorial. Okay. CD, desktop, Pytorch. All right. grep for target underscore. There we go. There we go. Data loading tutorial. This is what I want. This is what I want right here. Let's see. Target. Do we have a lambda? No. Okay. Let's grep for lambda. So I was doing this the whole time. Right here. Okay, so custom made it by custom. All right, we're gonna try copy. So one hot. Oh, all right, let's try this. Okay. Okay. That's what we were looking for. Okay, good to go now. Good to go now. Maybe. We're gonna find out. Let's see if that works. Yeah, lambda, because it's because we have to put it over here. Okay, that should do the trick. Oh, good. Oh, we did it. Okay, so what was the difference? Classes. What's the difference between these two? Well, one's a compose, so that's part of the problem. So let's just look at this though real quick. So let's compare these two here. Okay. Torch 0, Torch 0's classes, D-type float, scatter 0, Y. Well, seems it's not that much different. Okay. Okay. So we got the data. Where's our enumerate at? We got to go back to our enumerate here. Yeah, that's what I'm looking for. Okay, good, good, good. Now let's see if we need to transform. Nice. Okay. I think we did it. I think we did. We achieved it. We achieved the goal. Perfect, perfect, perfect. Check mark. Done. Let's move these things under the done section. Perfect. Okay. Success, success. I'm very happy with that. I'm very happy with that. So, did we do all the things we wanted to do? We've got one last thing, you guys. One last thing to do today. Did you put out the fire on the cabins? Hey, Scared. How's it going? Scared of werewolves? Welcome on in. Happy Tuesday. We're building convolutional neural networks is what we're doing. And then I want to add a writer dot. We're going to learn something new here. We're going to learn something new. We're going to visualize the model. Net and images. Net and images. Add a graph. We'll trace the sample input to your model if we run it once through. Oh! Add graph, net images. Okay. All right, let's try it. All right. Add graph. Oh, graph. Okay. So we're going to do this. So this will draw our model graph. So it should basically render the whole deal. All right. So it's called model, comma, images. We need to grab our data iter here, and we're gonna say images, comma, labels equals next data iterator, and that's it right there. I think we just did it. Loons. Phoenix wanted their BIOS to work on IBM computers. An engineer just looked at the IBM code and described it to another engineer. And they copied it. They copied it. Okay. Let's do fewer than 2,000 epochs. 20,000. All right, let's do just this. Yeah. Keep it there. All right. So now, in about a minute, we should see our graph. Although, I suppose we could see it now. There's no point. We could have done that in the early part. But let's just wait a smidgen. Okay. Visualizing your model. I hope it works. It might just crash. Let's restart our TensorBoard. Okay. How's it going there? Vinny Vidi Vici. Oh, Vinny Vidi Vici. How's it going there? I remember that from Doug. Is it possible to go from an idea to a product or a SaaS tool with only free tier AI models? Yes, it is. I think so. If you use the Gemma 4 AI model with the open, sort of like the open, what is that? You know, like the Claude Code and the Gemini and the Codex, there's an open source version of that. What is that called? What is open source version of Claude Code? It's open code. There you go. It's open code. So use open code with Gemma 4 AI model and you should succeed pretty well, I think. It's not state of the art. Open code, exactly. Exactly, Loons. So that's what I recommend. Use open code plus Gemma 4. Open code plus Gemma 4. And then you'll get as much freedom as you want. Has some good models for free too. Oh, nice. So open code comes built in with a bunch of free models. There you go. All right, did it crash? It crashed. No, we didn't do it right. Oh, we forgot to convert it over. Darn it. Okay. Fine. We'll start over. Did it capture any of the loss though? Okay, it did. Okay. All right. So we have to do .to device. I think that's it right there. I think that was the only thing that it was waiting for. All right, epochs. Let's say it's 200. 10 times faster. Nemotron and GLM 5.5. Really good models. Hey, it didn't crash that time. All right. Where's our output though? Where's our output? No. Where's our output, guys? We put it right here. Right here. Look. Oh, we need to flush, I guess. All right. Apparently, we got to flush it. Let's try it again. And then we will restart TensorBoard. Vinny Vici. The thing is, you've made some tools with free AI models. You've even posted Trading Indicator about 2 months ago and got about 113 downloads so far. Hey, very nice. But you're starting to second guess everything. That's actually good because you're starting to realize you can make it better. You can make it better. You're on the right track. Don't worry about second guessing yourself. It'll be a guarantee that you do that. Where is our model? Where is it? We flushed it out. We added the graph. You guys, where is it? Did we do it right? Okay. It's updating. It's all there. It's just not showing us the graph. You got to go, Loon. Sorry, no worries. It was good. You stayed for a long time. You got here at the beginning, and don't worry. We're wrapping up now. We're wrapping up. You stayed here for the whole stream, basically. That was awesome, Loons. Thank you. See you tomorrow. All right. I want to solve this one thing. Free tier models. You're not sure about how good it is. It's pretty good. Torva, you too. You've been here. You guys are so great. It's so much fun to be with you guys here. Okay, so I want to figure out why this is not working. Net images instead of model. Well, so in the tutorial they called. You're keeping your eye on this. You got good. You're good, Zergio. So net for them is the model. So if I scroll up here, this is their model. So they called it net. I called my model, right? Here's my model definition. Right here. I just called it model. I didn't call it net. I just called it model. Thank you. Yeah. You're keeping your eye on it. You're right. So this right here, I want it to work. I don't see why it's not though. Let's see. So we got a new iterator. We grabbed images labels. Did I do that wrong? No, I got it right. Images, commas, labels. Add graph will trace the sample input through the model, which is what I wanted to do. And render as a graph. It sure didn't though. What if we don't do any of that here? Let's only have nothing. Okay. Thank you for the hearts, you guys. The F word, it was good to see you too. We'll see you next time. Okay. Whoop. Now there's just nothing. There's nothing there. Scalars, images, histograms, all. There's nothing. Did it break? Time series? Scalars. Custom images. Audio. That looks neat. And histograms. No? Huh. Well, apparently this doesn't do anything. We copied the code perfectly. Hey, Steven, do you know of EA Nazier? I don't know. I don't think so. Visualizing your data set with embeddings. Select la la la. Select random. Class labels. Feature images. That actually would be pretty neat to try this. Wouldn't the more interesting stuff deal with reinforcement learning and like how tokens are clustered something? So that's where you get into the fine tuning. So what you do is you're talking about the initial training is unsupervised and it just learns patterns over the repeated data set. And then you want to fine tune it with reinforcement learning to give it objectives, and you have the model run until it meets those objectives. And you try to have it run on fewer and fewer amounts of iterations to be successful. So that way it can get to the answer more quickly with less time and less compute. So you basically give it a goal. So Kyle, that is in fact pretty exciting. Some scammy merchant selling subpar copper. What? Immortalized in what is that word? Some sort of tablets. I don't know what that is. He may have sold bad copper and treated your messengers with contempt, but you've heard of him. Oh, really? Okay. First customer service complaint in record history. Oh, what? No way. Is this a live Python stream? It sure is. Hey, how's it going there, Big? Welcome on in. Good to have you here. We are going through Pytorch, and we're currently on at the very bottom here of this TensorBoard tutorial. I've never used TensorBoard before this tutorial, and it's okay. It's fine. However, there's this part right here, which is so simple, it's not working. It doesn't do anything. It's empty. It's completely empty. And it's not like it wasn't working before, because we have stuff that works. It works. Oh, it works. Heck yeah, dude. Nice. Mind taking a look at my projects when you can? I'd love to know what you think. Sure, Vinivici. Absolutely. Vinivici. You got it. So, see, you can see our loss, which shows up really nice, right? You can see that pretty nice right here. Looks good to me. I like it. The problem is, that's the only thing it shows. It doesn't show anything else. And I want to see other things. It's not showing. It's just not. It's not showing you guys. I really wanted to see it. I wanted to see what that looks like. Oh well. When you switch over to TensorBoard, you should see Graphs tab. Oh, there's a Graphs tab? I just gotta keep reading it. Graph. Oh, there it is. Hey. Okay. We just gotta read the documentation. All right. Is that the learning rate? The learning rate is 0.001, I think, right? There you go, learning rate. We found it! All you gotta do is read the docs, okay. Although, that's not that impressive. Honestly, it's not that impressive. We found it. It took us a while, but we found it. Oh, that's kind of neat. So you can see where the device is. Trace. Okay. Our graph is too simple, apparently. Our graph is too simple, you guys. Well, in that, I do believe that we essentially achieved our objective for today. Let me see if there's anything left. So there's this one last thing here that I'm just going to copy and paste because I think I achieved everything I wanted with TensorBoard. Let's see. La 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 la. All right. We're going to comment these things out here. We're going to leave that. We're going to paste it in. Set paste. And we're going to see what happens. Do we have some of these things? I don't know if we have training set. We do. Okay, we have this. Data la la la. Looks good, looks good. Okay. Images looks good. Yep, okay. All right, we should be able to see whatever this is. I don't know what this is. Let's read what this is, and this will be the last thing. The 28 by 28 image tiles that we're using can be modeled as a 784 dimensional vector. It can be instructive to project this to the lower dimensional representation, to project it as a set of data in 3 dimensions with highest variance and display them as an interactive 3D chart? No way! Method does this automatically by projecting the 3D dimensions to the highest variance. If you switch the TensorBoard to the projector tab, we should see it. Although, it has no object training set.data. Okay. So what I'm going to do, instead of doing random, is I'm just going to say next. I don't care about this. All right, let's try that. They're overwhelmingly trained on English. Ooh. Training set. Yeah, that should work. That's perfectly fine. I'm using that right here. Oh, here. I've got a better idea. All right. Have you used dimensionality reduction? Yes. Absolutely. Label. Images. What's weird here? Images labels, class labels. Class labels. Label for label and labels. It's right there. Labels and labels. Classes. Oh, I don't have a class. Do I have classes? All right, hold on. Oh, got it. Okay, we don't have that because we're using animal pictures. Classes labels. What I'm going to do is I'm just going to make that a number. Okay. Like this. Watch this. That should work. I don't know, maybe. Okay. Shape 784 is invalid for input size of very big. Oh, right here. Okay. So we need to convert that. I believe. Do we have another view? 28 by 28. Let's try this. See, let's get it close. At least it'll get us a little bit closer. Also, epochs. It's gonna be like 20. It's still not big enough? Because the image is massive, by the way. It's massive. Alright, it's going to be a huge image. So, I've got an idea. There we go. Easy mode, maybe. Label should be equal with data points. What line? Where are we at here? Add embedding features. Oh, okay. Writer to add embedding features. I've got a very big features. You just don't think AI is a sci-fi utopian tech some people think it is? Yeah, we're not there yet. You're right. We're not there yet. Maybe when we get normalized AI robots, it'll be different when we get the robots, you guys. Once we get the robots. Okay. So I'm on this very last part here of this final bit of the tutorial. It'll feel so good to finish it. It'll feel so good to finish this. I just need to figure this out. All right, so The features are too big. Labels should equal with data points. That doesn't make any sense to me. Labels should equal with data points. Oh. Images should equal with data points. Yeah, I don't get it. I don't get it. Here, what we're gonna do though is it's because they want fashion imness. So I'm just gonna grab this and we're gonna overwrite it. Where's our training set? Here we go. Okay. So we can restore the view. It is negative 128, 28. Okay. 28 by 28, which is 784. Okay. It's 784, invalid for input size of 90. So what are you talking about? Here we go. All right, I figured it out. It's just a little bit at a time, you guys, a little bit at a time. Labels, ooh, it's right there. It's right there. It's right there. Int object is not iterable. It is a label. Oh, it's a label. All right, let's just comment that out for a second. Don't care about that. And this, it's not a labels, it's a label. So it's still not big enough. Okay. Oh, did we not so we need to define a transform up here. 1 second. Our transform's different now because we changed it. So let's wrap this little bit of it up. Where it is, here's our transform. Okay. There we go. Looks good to me. Okay, now it should be good. How's it going there, Titania? Good to see you. Welcome on in. Hey, it worked. You joined at the right time, Titania. Check this out. Okay. So we should be able to see our TensorBoard graphs. Yeah. Time series, scalars. Model training loss, yeah. So which one are we supposed to look at again? Where was that at? All right, this is the last thing on the tutorial. This is the last thing, you guys. We got it to work here. So now if you switch to the TensorBoard projector tab. All right, so we need a projector tab. Projector. It doesn't, there isn't one. I don't see a projector tab. Oh man. Oh man, really? There's no projector tab. Here, let's rerun it. Restart TensorBoard. Reload. Okay. Thank you for the reactions, you guys. Okay, where is our projector? Project. There's no projector. Custom scalars, images. There's no audio. No graphs. Maybe distribution? No. Debugger? That looks neat, but that's not it. Time series, scalars. Did we flush and close? Yeah, we flushed and closed it. Maybe we need this part here. There we go. We're gonna try that. So that should work. Okay. Projector, there it is. Well, it doesn't look like anything, but we got it. We got it. We got the projector tab. Can we say batches? Batch size equals 8. So this will actually be labels now. Try that. MNIS got an unexpected argument batch size. Oh, it won't let me do batch size here? Oh, that's on our data loader. Okay, 1 second. Where's our data loader? It's training set. It's been replaced. And we've got an iter. Oh, all right. So we need a data loader. Data loader. Loader. Where's that at? Here. There we go. So let's use this instead. All right. Data loader. And this is going to use training set. Yep. Batch size of 8. Okay. And then we don't need, do we need this? Hold on. Yes. We're going to go off of this. And that should get us a batch of 8, which should give us more data. Okay. How's it going there, Maggie? Good to see you. Welcome on in. Thank you for clicking the hi button. Training loader. Did we get this wrong? Yes, we did. No. Wait. Where are we supposed to use this at? Here. That should do the trick. Okay, let's try that. I really didn't like that. Okay. Yeah, because there's only one. All right. Well, I'm going to call that good enough for now. So we got our tab. It shows up. Let's go to... and we see a very pretty nothing. We see a very pretty nothing. We copied the code. It went. And also, I kind of don't care about this one. I kind of don't care. I don't need to visualize that. All right. I'm going to commit this. Git status, git commit am. We sort of added projections and push that to master. Okay. All right, that's good enough for now. Hey, everyone, thank you for joining in for today. Tomorrow we'll be back and we'll be doing some more Pytorch. We finally got past this. I'm gonna call that done because we've been on TensorBoard for so long. Now we're gonna go into this next segment, and this is where we'll start with tomorrow. I sent you an email, sir. All right, Benevici, sounds good. What are we creating? Chaitanya, we are trying to become Pytorch experts, so we're walking through all of the tutorials. The last tutorial that we were just on was a convolutional neural network that we messed around with a lot. We went way off of where the tutorial was, and we kind of built it our own. We used animal pictures instead of clothing pictures, which was a nice change. And then we changed how we transform the data through our ConvNet. So the plan is, tomorrow, we're gonna go and continue on with our journey of becoming Pytorch experts. And we're going to move on with this next tutorial. Sounds good, Bonzupi. Thank you, everyone, for joining in. We're going to be back tomorrow. See you, Loons. See you, Bonzupi. See you, Kyle. See you, Chaitanya. See you, Magi. Good to see you, guys. Zergio, good to see you. Have you answered the rest of your day? Oh, have an awesome the rest of your day as well. See you, guys. Have a good one. We need Pytorch expert badges. Yes, we do. Yeah, we do. Good plan. Good plan, Kyle. So good to see you, Kyle. All right. We're heading on out. We'll be back tomorrow. Bye, everybody. Have a go. What was it? Noel, thank you for subscribing. You clicked the button right before we ended. Chaitanya, wishing you luck. Thank you, Chaitanya. Noel, good to see you. All right, bye, everybody. See you tomorrow. Have a good one. See you next time.